percents. So before we start, percents are basically proportions, so I guess as a prerequisite for this video you should probably already know proportions. Okay, so if you haven't seen it, if you don't understand proportions, go back and watch the proportion video. Okay? Alright, so percents, as I was saying, I solve percents typically with a proportion. I use the proportion because it works every time. There's different ways to solve percent problems, but this way works for all the different kinds of percent problems that you might have. So the basic proportion in general terms is part over whole is equal to percent over 100. Okay? I mean over 100%. Now when you write your proportion, like when you're just going to write it out blank, you're always going to have the 100%. So that number is already there. Okay? There's always going to be something that's equal to the 100%. So we put that percentage right there automatically. So the three that are left, I guess blank would be this blank percent, the part, and the whole. Now in a percent problem, they're going to give us two of those three slots, or two of those three pieces of information. So they could give us the part and the whole and ask us for the percent, or they can give us the part and the percent and ask us for the whole, or they can give us the whole and the percent and ask us for the part. It just depends on the question, right? Okay. So as with all proportion problems, at least for my students, the hard part typically tends to be when they have to set up the proportion correctly, so that when they do the multiplication and the division, that the answer comes out correct. So percents are no different. We have to set them up correctly, and the hard part really is identifying the part and the whole. It's not always hard, but sometimes it is. Okay, so on a simple problem, or what I would consider a simple problem, you're going to see these words, is and of. In fact, some teachers like to teach this proportion. They like to teach that with is over of is equal to the percent over 100. But the is over of method is only good with the simple problems. When we get to more complex problems, the is over of just doesn't work that well. So we have to have more ways of identifying the part and the whole. And we'll talk about that. So, I mean, when I talk about easy problems, I'm talking about ones like this, right? I guess I could do something like that. Right, so this one says, what percent of 40 is 25? Right, so when you see the word is, here, the number or the amount that comes immediately after that word is going to be the part. That's the part. And then over here we have whole is of. So whenever I have the word of in a problem, the next amount, the amount that comes immediately after of, is going to be it's not going to be 40. It's going to be the whole. Okay. There we go. All right. So we're going to do these ones in a minute. We'll get back to that. Talking more about whole. So if we don't have the easy kind of problem, then we have to look at it more in these terms. The whole is going to be the original amount. Okay. So original amount, what does that mean? Let's say there's a sale going on in a store, and they discount something, right? 20% or 50% or 30%, whatever. Now, the original amount is the cost of the thing that you're going to buy before you apply the discount. Okay, so it's before putting the 20% on it. What was it before that? That's going to be the whole. That's the original amount. Now, there's also problems like salary problems, or, well, we'll just say salary. And we can even think about it as in a temporal aspect. Temporal means time. So let's say let's use me as an example. Let's say in the month of May, I'm making $10 an hour. Next month, I'm going to get a raise, and so I'm going to get $14 an hour. That's really a great raise if you can find it, right? So let's just say this in like a word problem, right? Let's say, in May, Raul earned $10 an hour. Next month, he will earn $14 an hour because he's getting a raise, right? And the thing that my students do immediately when they see these kinds of problems is they take the 14, and because it's a larger number, they think that's the whole, and they put that in the whole position. And then they take the 10, because it's a smaller number, they put that in the part. And then they get the problem wrong. So we have to think about what comes first, May or June, right? Which month comes first? May does. So what was I making in May? That's the whole. That's original. That's the earlier form of my salary, okay? All right, so that's what I mean by original amount. So always try to look for that. And part, when it's not one of these is or of kinds of questions, we have to think about the part as a difference in change. And so what does that mean, right? It's a little confusing, I guess, but let me explain. Difference. What does difference mean? Difference is a subtraction. Actually, it's the answer of a subtraction. It's the answer after you subtract two numbers. So obviously, that means that we're going to be subtracting two numbers. What are we subtracting? Well, difference of change. What's changing? If we go back to my example about making $10 an hour in May, and $14 an hour in June, how much did my salary change? That's where the word comes from, right? I mean, the change. We're not talking about the change in your pocket. We're talking about the change in my salary. And what's that difference? Okay, and so to find that difference, you would have to subtract the new salary from the old salary, from the original salary, from the whole, right? So I'll say that again. The new salary subtract the, let me say that one more time. Subtract the old salary from the new salary, 14 minus 10, and we're left with 4. 4 is going to be the part. That's the difference. This difference, right? That's the difference in my salary. That's what changed. So, somebody says, well, you got a raise, so what are you getting? They're not asking what are you making now, or, well, they might ask what you're making now, but I guess they really want to know is how much of a raise did you get? What's the difference in your pocket every month? You know what I mean? And at least per hour, it's $4. All right, that's what I mean. So we have to pay attention to this. We want to really get used to looking for original and looking for part as difference. What changed? Okay, sometimes that difference can go up, like a raise, or maybe I didn't do a good job this year and I get demoted and they pay me less. That's just an example. But what I mean is that change can go larger or that change can go smaller. So it just depends on the question, okay? So let's take a look at these easier ones that I think are easy anyway. So the first one says, what percent of 40 is 25? All right, so let me set up my my proportion. Now you guys should write this stuff down. Keep it in your notes. It might come in handy later. You never know. So I'll stop. You guys wrote it down? Cool. All right. So to set up my proportion, remember it's just two fractions that are equal to each other. The second one is always going to have that 100%. Okay? All right, so now we know that this is going to be a percent. We just don't know what yet. So let's take a look at the problem, see what they're asking us. Actually, they're asking us for the percent. What is the percent? So we're going to be solving this for that percent. Remember of is going to be the whole, right? It points to the whole number, or the whole the whole of our percent problem. So of, the number that comes after, that's the whole. That's 40. Remember that the whole goes in the denominator. And then is pointing to the part. Okay, so is 25. And now we're ready to solve this. That's not too bad. Like I said, setting up the proportion is difficult. When there are easy problems like that one, is over of, it's not too bad. All right, so to do the proportion, remember that we just multiply diagonal. 25 times 100 is 2,500. And we'll divide that by the third number that we haven't used yet, and that's 40. Okay. We do the division, and that should give us 62.5. Okay, so 62.5%. All right. It kind of makes sense. There's a little bit of logic that goes here. Well, a lot of logic, but there's logic in this problem. If we're saying that 40 is equal to 100%, ask yourselves, what would 50% be? 50% of 40 would be 20, it'd be half. Okay? So there's a little, you can think about this a little bit. So if half is 20, or 50% is 20, then, well, I don't have 20, I have 25. I have a little bit more than half. So I know that my answer needs to be more than 50%. So, and it is, it's 62.5% to be exact. But it makes sense that it's a little bit higher than 50. Okay? All right. Let's do another one. And I'll go ahead and set up the proportion again, just ready to go. Okay. Let's take a look at the second one. 16% of what number is 200? All right, well, this one's a little bit different. This time they gave us the percent, not like in this one where they were asking for the percent. So it's a little bit different. So I know where the percent's going to go, right? It's a 16, so we can put that over here with the percent, where the percent goes in that spot. What's the 200 going to be? Remember, is points to the part. So the number that comes after is the part. So 200 is the part. So we have to think logically here. Well, we don't have to, but we should. And start trying to visualize what that number, what our answer is going to be. If we're saying that 16% is 200, or 200 is equal to 16%, the 100% needs to be bigger. So I know that my answer has to be much, much bigger than 200. Okay, because 200 is only 16%. I want 100%. So I know it's going to be bigger than 200. Okay? But let's go ahead and do it. So again, setting it up is the hard part. Those are the easy ones. We'll get to more interesting ones in a minute. So we multiply diagonally. We get 20,000, I believe. All right? Yep. We divide by 16, the other number that we haven't used in the proportion. And when we do the division, we should get 1250. All right? So I was right. I knew that 100% had to be a lot bigger than 200. Okay, because 200 is only 16%. All right. So that's basically the basic fundamental concept of percent problems. It's a proportion. But let's play around with a few that can be a little bit more tricky. All right? Okay. So we'll just pull this guy over. I would suggest maybe you guys giving it a shot. Why not? Why not pause the video now? I'll read the problem, pause the video, see if you can do it. And then I'll do it, and we'll see if we're on the same page. All right, so let's see. I'll read it here. It says, Ruby is buying a pair of shoes that normally cost $65. Today the shoes have a 20% discount. How much will Ruby pay for the discounted shoes? And there should be a period over here. Anyway, so how much will Ruby pay for the discounted shoes? Go ahead and pause the video now and try it out. Okay, I'm going to go ahead and do it. So again, I'm going to set up my proportion. Okay. Let's examine the problem a little bit. Okay, we have this girl, Ruby, new shoes, normally cost $65. We have a 20% discount. What are they giving me here? What's the information we have? I think this one's going to be pretty easy to locate, right? Seems like the 20% is going to go over the 100%. Because we have that, we have a little percent sign. Be careful, it's not always like that, but usually it is. So I guess we just got to think about the 65. What would the 65 be? Now remember, we haven't applied the discount to it. We haven't done anything to I said it right there, I was going to say it, I'm going to say it anyway. We haven't done anything to the original cost. So that original cost, untouched by the discount, is going to be our whole number, okay? It's going to be our whole part, our 100%. All right. So this one wasn't too bad. I think a lot of you probably had a lot of luck with getting this one set up correctly. So we multiply diagonally, and that should give us 1,300. We divide by 100, and just cancel out my zeros, and I get 13. So 20% of 65 is 13, or 13 is equal to 20% when 65 is equal to 100%. All right. But let's read the question one more time. The question here, I mean, this is really where the tire hits the road, so to speak. This is where we have to really pay attention. How much will Ruby pay for the discounted shoes? It's not asking us how much will be discounted. Do you see the difference in that kind of question? So this kind of problem has at least two different ways of asking the question to us, the people that are answering the question. They could ask, how much money will she save? $13. Or they can ask us what this one's asking, and that's how much will she pay after they take off the $13. So, and I have that happen a lot. I see that sometimes with my students. They, sorry, can't talk when I'm subtracting. My students, they'll do all this stuff right. They set up the proportion correct, and they do the thing, they do the operation, they get 13, and they answer 13. And I'm like, no, it's not 13. You got to read the question. You got to read what they're asking you for and make sure you pay attention to that. So I would always recommend to my students and to all of you, when you do the whole thing and you get your answer, before you say, I'm going to write that in my answer sheet or on my test, I'm going to put that as my final answer, before you commit 100%, just read the question one more time. Make sure you're answering what you need to answer. Okay, because those are the silly little mistakes that frustrate us when we could have had a 100% and they give us a 98%. We're just like, oh, was that close? This close. Okay? All right, so we saw the easy ones. We saw the is over ub kind of problems. We saw one with a discount, like a 20% discount. Now we're going to see a couple more that are, they get more interesting, to say the least, okay?